Hi there, welcome back to another A-level maths video, and today we're going to be talking about solving quadratic equations. Now there are two kind of key methods I want to cover in this video. So the first one we've looked at in a previous video, which is just solving by factorizing. So an example of this would be perhaps something like x squared minus x minus 25 is equal to 5. So how would we go about solving this for x? Well, first of all, we'd want to rearrange it so we get it in the form of a quadratic equaling 0. So we could see here we could take 5 from both sides to give us x squared minus x minus 30 is equal to 0. And then we want to factorize this into some brackets. So we want two things that multiply to negative 30 and add to negative x. And you should be able to see fairly quickly that that would be x plus 5 and x minus 6. So plus 5 and minus 6 multiply to minus 30, and 5 minus 6 is minus 1, and that gives us our minus x here. Okay, so now we've factorised it, then we can solve for x. And the way this works is basically if we have two things multiplied together equaling 0, that must mean that either one of these brackets or both of them equal 0, as that's the only thing that would cause the product of them to be equal to 0. So we could either have then x plus 5 equaling 0, or we could have x minus 6 equaling 0. So x is therefore minus 5, or x is positive 6. Now, we can also get cases where we might factorise, but the brackets we get are both identical, and that's what's known as a repeated root. So if we had 9x squared plus 30x plus 25 is equal to 0, well, this 9x squared is actually 3x all squared, isn't it? And this 25 here is actually 5 all squared. So that says to me that we might have some kind of repeated root. So if we had 9x squared, we know if we were to factorise this into brackets, that would have a 3x at the start of each bracket. And I'm just going to guess here, because we have a 25 at the end, that both of these brackets are plus 5. And so if we work this out, then we're going to have 3x multiplied by 3x, which would give us our 9x squared, and then our 3x multiplied by 5 plus another 3x multiplied by 5. So that's two lots of 15x, which gives us our 30x, and then these two 5s at the end multiplied to 25. So we can see that this factorisation is correct. And of course, because they're both identical brackets, we could rewrite this as 3x plus 5 all squared. But basically what it comes down to is that therefore 3x plus 5 must equal 0, and 3x must equal negative 5. So x is going to be negative 5 over 3. Cool, so that was our first method, or using factorising as our method. You can sometimes get really easy examples where you don't even need to factorise at all. So we could have something like 2x minus 1 squared is equal to 7. And we might come on to something that looks similar to this in a following video where we do completing the square. But in this case, all we have to do is get rid of this squared bracket. So we can do that by square rooting both sides. So we'd have 2x minus 1 is the square root of 7. Now we do have to be a bit careful here, because the square root of 7 all squared gives 7, but the square root of minus 7 all squared would also give us 7. So if we take the square root of 7, or square root both sides in this case, we need to ensure that we account for that possibility that it was negative square root 7, so we need a plus or minus here. So then we can continue with our simplification or rearranging for x. So we could end up with 2x is equal to 1 plus or minus root 7. And then x is going to be 1 plus or minus root 7, all divided by 2. So that's a solution in that case, requiring no factorising because it's essentially already in a form where we can find x easily. So I said there were two ways of solving quadratic equations we'd cover in this video. And the second then is, of course, a case where you can't factorise. So in this case, we have x squared plus 4x minus 9 is equal to 0. And if you're trying to factorise this, well, we'd want two things that multiply to negative 9 and two things that add to 4. In that case, if we think of two things that would multiply to negative 9, well, our only options are 1 and negative 9, or negative 1 and 9, or 3 and negative 3. And you can see none of these combinations are going to add to give us 4. So we can't factorise this expression. So instead, we're going to have to use something else, and that's where we use the quadratic formula, which you might have already covered in GCSE. But the quadratic formula is basically if we label each of these components of our quadratic equation a, b, and c. So the coefficient of our x squared, we're going to call that a. The coefficient of our x, we're going to call b. And this constant we have at the end, well, it's including the negative, that's what we're going to call c. So if we have our quadratic in the form of this equaling 0, then x would equal minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's come back to this example then. So we know that b is positive 4, so we're going to have minus 4 plus or minus the square root of b squared, so 4 squared, minus 4 lots of a, multiplied by c, which is negative 9, so we include that negative. And sorry, this a is 1, all over 2a, which is just 2 lots of 1. So then we can just simplify this. So we're going to have minus 4 plus or minus the square root of 16 plus 36 all over 2. And that's going to be minus 4 plus or minus the square root of 52 all over 2. Now, if we think back to surds, then the root of 52, well, that's the same as the root of 4 times 13, which is therefore the same as 2 root 13. So if we now have minus 4 plus or minus 2 root 13 over 2, well, that's the same as, we can now divide everything by 2. So minus 4 divided by 2 is minus 2, plus or minus 2 root 13 divided by 2, well, that's just going to be root 13. And so that would be our solution. And when we have a plus or minus here, well, we can just remember that that's basically giving you two solutions, isn't it? Minus 2 plus root 13 and minus 2 minus root 13.